Hello friends, this is Eric White. Today I have the pleasure of announcing a new module in Open-Xml-PowerTools. This new module, HtmlToWmlConverter, takes HTML that is formatted with CSS and produces canonical word processing ML from it. This means that you can take web content such as pages from a website, or you can take HTML as generated by rich editors in your web application or in your SharePoint application, and you can convert that HTML into ordinary word processing ML with all formatting applied, fonts and bolding and styling and indentation and so on. I think the easiest way to get going here is just to demonstrate this to you so you can see what this module does. Here I'm in the Open-Xml-PowerTools directory as cloned from GitHub. If you have any questions about how to download the Open-Xml-PowerTools from GitHub and how to build it and get these examples, take a look at this screencast at this link. I'm going to open up this Open-Xml-PowerTools examples solution here. There are two examples here for HtmlToWmlConverter. Let's take a look at this first example right here. In this HtmlToWmlConverter 01 directory, there are various HTML files that we're going to convert to docx. The example iterates through every HTML file that it finds in this directory and converts it. Let's run the example. And there it ran. After running the examples, you can find the output of the examples in bin debug and in this example output directory that has a date time stamp on it. And here we can find the file as converted by the HtmlToWmlConverter. And when we look at it in Word, you can see it's a pretty good representation of the original HTML file. Here's an example that has a little calendar in it with some items at various places in the calendar. This demonstrates a conversion of a table with various types of styling on that table. And here is the docx as converted by HtmlToWmlConverter. Here's another example. This is a table that has an image in a cell, and we can see that that table with the image in the cell in it is converted very nicely to word processing ML. Here is a pretty typical word processing ML document with various types of styling in it, various types of bulleted text. Here is a nicely formatted resume. We can see that this resume was converted to word processing ML quite adequately. Here's another table that has various background colors, various fonts applied to it, and we can see how this particular table was converted to word processing ML. Here's a document that's in Chinese, and we can see it's converted quite nicely. One thing that is interesting is to see the performance of this new module. The HtmlToWmlConverter is an interesting example in that it first uses document assembler to generate a fair number of documents. I believe it generates 100 documents. It then converts those 100 documents to HTML using the HTML converter. This is the HTML converter module that we've been using for quite some time in Open-Xml-PowerTools. It then turns right around and uses HtmlToWmlConverter to convert all of those files from HTML back to docx. So in effect, it generates all of these documents, and then it does a round trip. It converts them to HTML and then converts them back to docx. And we can see the fidelity of this conversion by running this example. We can also see the speed of this conversion by running this example. I'll set that as the startup project and run the example. And here we can see it clipping right along, generating documents, converting those documents to HTML, converting that HTML back to a docx, and there it's finished converting 100 documents just that quickly. Let's look at the output of this example. As I mentioned, we can find the output of all of the examples in Open-Xml-PowerTools in the bin debug directory in an example output directory that has a date time stamp on it. If we go in here, first of all, let's look at letter 0001.docx, and we can see there is a sample document that has various types of styling applied to it. Here is that document as converted by HTML converter into HTML. We're looking at it in the web browser. And now if we look at it again in Word, after being converted from HTML back to docx, we can see the resulting document. You'll notice here and there are some small issues associated with round-tripping such content, such as borders on certain types of paragraphs. However, it does a pretty good job. It certainly takes care of character formatting, it takes care of fonts, it takes care of vertical and horizontal spacing. My goal with this wasn't 100% fidelity. My goal, at least at this point for V1 of this module, is good enough fidelity so that we can take HTML content wherever we might have it and include it in a generated document in a fairly nice, predictable way. So at a high level, what did I have to do in order to get this module put together? Well, first of all, I had to get a CSS grammar and generate a CSS parser. This CSS parser is just about as rudimentary as you could get. All it does is make the various CSS directives and properties available to us through a simple API. We can find this code in this HtmlToWml CSS parser. At that point in time, after parsing all of the CSS, then it's necessary to apply that CSS to the HTML DOM tree per the rules of CSS, and that's what this HtmlToWml CSS applier does. I'm not going to go into all of the details of this particular sub-module. Chances are you won't need to make any changes either to the HtmlToWml CSS parser or to the HtmlToWml CSS applier. After getting a DOM tree with all of the CSS directives and properties applied to that DOM tree, then the only thing that was left was to write a recursive pure functional transform from this DOM tree into canonical word processing ML, and that's what this HtmlToWmlConverter core module does. The HtmlToWmlConverter module that we can see right here, this is just the public interface to that API. So the question is, why do we need this module? Well, some of you know already why we need this module. Some of you have used rudimentary versions of an HTML to word processing ML converter. But if you don't know why we need this module, we might have a large database of products where the product descriptions are stored as HTML/CSS. We might want to generate letters to customers that include product descriptions. For instance, confirming the products that they have ordered. We might be writing a SharePoint solution using a rich editor, and we might want to incorporate that rich HTML/CSS into a generated document. We might be building a large web app where the end user maintains custom biographies or custom product descriptions, and we want to incorporate that information in a rich form in a generated document. The most common use of the alt chunk approach in Open-XML is to incorporate HTML and CSS into a document. However, there are a few issues with using alt chunk. The biggest issue is that in order to see or process the word processing ML, we have to first process a document that contains alt chunk content, either using Word or Word automation services. In contrast with HtmlToWmlConverter, immediately after running it, we can see the canonical word processing ML and we can further process it. Another reason is that alt chunk is essentially a black box. We can't impact how it transforms from HTML and CSS into word processing ML. There are a few cases where it actually doesn't do a great job, and our only option is to either pre-process the HTML and CSS and put that HTML and CSS into a form that alt chunk can process properly, or we have to post-process the word processing ML after we have automated Word to convert that alt chunk content to canonical word processing ML. In contrast, because you have the complete source code for HtmlToWmlConverter, as necessary, you can add hooks to alter that conversion functionality, or you can directly change the functionality. I'm certain that we'll be enhancing HtmlToWmlConverter in the future. Another reason is that alt chunk doesn't play nicely with non-standard HTML or CSS. I have, in the past, written some code to go into non-standard HTML and whack and hack on it to make it standard HTML that the alt chunk functionality of Word can handle. But we can certainly enhance HtmlToWmlConverter to deal with non-standard HTML. I had set out 4 main goals when I wrote this new module. The first goal is that it should be completely reliable and robust. We're running this code on a server and we need it to not crash. So reliability is of prime importance. Second thing is, it should always, no matter what, generate a valid word processing ML document. It's not acceptable to generate a word processing ML document that doesn't validate per the Open-XML SDK after generating it. You can see in the HtmlToWmlConverter 01, it validates the document after converting the document to word processing ML. Further, if you look at the XUnit tests for HtmlToWmlConverter, you can see that those XUnit tests also run the Open-XML SDK validation on the documents after converting them from HTML to word processing ML. The third goal is it should do the right thing. And notice that this is the third goal. This is not the first or the second. First is it needs to be reliable. Second, it needs to generate valid word processing ML. And the third goal is it should do the right thing. We want as good a representation as possible. I know that there are a place or two where it's not perfect. The focus in this module is on getting a reasonable representation of that HTML. So, for example, I didn't write code to fabricate styles for the various CSS classes. It generates word processing ML with formatting directly applied to the paragraphs and runs. What we really want to do is we want to get that HTML into our word processing ML document with high fidelity. We don't necessarily have to have it be styled with style names and styles in the word processing ML. Now that you understand what this module does, I want to cover a few technical points about its implementation. Because I used a recursive pure functional transform, which is the most effective way to write these types of transforms, I use a linked XML tree to hold the HTML. You can see here where I declare an X element and call this method HtmlToWml read as X element method. This gets us that HTML as XML. Let's take a quick look at this read as X element method. One thing that you'll find is that if you have HTML that cannot be read as XML, the X element parser will throw an exception. Well, there's an easy solution to this. The HTML agility pack has capability to load that HTML and save it as XML. So if you define this use underscore HTML agility pack, then it will use the HTML agility pack to convert that document from HTML to XML. There's a little bit of house cleaning that we have to do with regards to entities that as we read that HTML and convert it to XML, you can see all the code here that is necessary to do that. I have that undefined in the standard Open-Xml-PowerTools examples because I didn't want to require that you have the HTML agility pack installed in order to run the Open-Xml-PowerTools examples. One note about the HTML agility pack is it's also licensed under the Microsoft public license, so there is no licensing issues with using it in your application. If you're okay with using the Open-Xml-PowerTools, which are licensed under the Microsoft public license, then it will be equally no issue to use the HTML agility pack. The Microsoft public license gives you wide latitude in how you use this code, including you can use it in your commercial applications. You don't necessarily have to contribute any source code changes back, although we certainly like it when you find bugs and help us fix them. Let's go back and look at this call into the HtmlToWml converter again. We can see that we pass in 3 different pieces of CSS. There is the default CSS. This is the CSS that, for instance, every browser will apply to HTML. If you don't supply any CSS, well, the browser is going to apply some level of CSS styling to that HTML. The next thing is this used author CSS, and this is the CSS that you can get from the style element in your HTML. I have this method here, clean up CSS, that goes through and does the various things that you might need to do to properly process that CSS. Sometimes that CSS is commented out with either XML comments or C style comments, and the CSS parsers in browsers know to still process that CSS. Well, we want to pass in CSS here that the CSS parser can handle easily, so this clean up CSS does the necessary stuff to make that CSS into a form that the CSS parser can process properly. I want to make one note about the CSS parser. In many browsers, the CSS parser is exceptionally forgiving with regards to syntax errors or malformed CSS. However, I found it was somewhat problematic to have the CSS parser be not strict. I, for instance, would code some CSS and I'd look at a conversion and I wouldn't see the conversion appearing as I wanted it to appear. And really the problem was the CSS parser was catching exceptions and I wasn't trapping those and noticing them. So by the time it actually got to the converter, the HTML elements didn't have those CSS properties and the conversion didn't happen properly. So I made the decision, at least for right now, that the CSS parser is strict. It parses the CSS and it throws exceptions if you have any errors in the CSS. You should be passing in clean CSS into the HTML-to-WML converter. The next thing that I want to discuss are the HTML-to-WML converter settings. There are lots of things that we need to know about a word processing document that are not defined in HTML, such as the page size and what are the margins on the pages and so on. We can control all of that through the HTML-to-WML converter settings. There are some convenience methods to help us with this. We can call get default settings, and this gets us the settings that we would see for a typical document where in Word you just new up a document and it creates a page with default margins and a default page size. However, if you want to have different types of settings for your conversion, there's an overload of this get default settings that takes a WML document. And this then retrieves all of those settings from that WML document. If, for instance, you want to create a document that is in landscape mode and has particular margins, then you can create a document that has that particular page layout and has those particular desired margin settings, then pass that document into get default settings, and then you'll get a HTML-to-WML converter settings object that will give you those characteristics when you convert that HTML back to word processing ML. Regardless of how we get these settings, one setting that we have to explicitly set is the base URI for images. In the HTML, there will be references to images, and we need this base URI for images so that we can go find and load those images from whatever HTML source that you have. This would typically be the directory name that contains the HTML file, and in that HTML file it will refer to images via a relative path to that directory. We can see here that when we call HTML-to-WML-converter.convert HTML-to-WML, it returns a WML document. This is an Open-Xml-PowerTools object that is essentially a very thin wrapper over a byte array. So what we're working with here is a document that's stored in memory. We haven't saved it to disk at all. So after getting that WML document back from convert HTML to WML, we can then save it or dispose of it as desired. We could, for instance, in a web application, make this document available to the end user to download. One of the things that's great about this converter is it's a recursive pure functional transform, And that means for those of you who are schooled in the art of recursive pure functional transforms, that this code is not brittle. It can morph very easily. We can enhance this code going forward. So if there are places where this converter isn't meeting your needs, feel free to file issues and we'll enhance this HTML2WML converter to make it more and more capable going forward. I intend to incorporate this converter directly into Document Assembler so that in the Document Assembler we can automatically incorporate HTML content into generated documents. If you're not familiar with Document Assembler as an approach to high-performance generation of Open-XML documents, take a look at this screencast. It will fill you in with all of the details of what Document Assembler can do for you. So stay tuned. Watch for enhancements to this module going forward. It's in pretty good shape right now, and I expect that we'll continue to enhance this in the future. Thanks for watching. See you in the next video.